Good morning, students.
Good morning, sir.
So, I hope all of you remember we had discussed this particular issue. Well, you know, the ray traveling into a structure, a piece of glass. This is a piece of glass, and this is air, and we have discussed the ray diagram for this, right?
Yes.
Now, I told you how to handle this ray diagram. That is, you know, the ray is entering here, it is monochromatic, and then the refracted ray is here. And then, as far as the emergent ray is concerned, there are three conditions to be considered. One is if it is incident here perpendicular, then it will come out straight. And if it is incident here at some angle I less than the critical angle, then it will be like this. And if it is critical angle, then it will skim along the surface. And if the angle of incidence here is greater than critical angle, then you will have total internal reflection, right? And this is nothing but, you know, what I have drawn here structure is, if you extend it, it is going to be prism. So this is basically a prism. All right. So now we will see whatever I explained practically, right? That is the idea behind experiential learning. So whatever I have said, you can experience it practically here. I have got a source of light here. So the light is coming here. You can consider it as a ray of light. And you can see I have coincided that with, I mean, I kept a prism here basically. You can see that this is a prism here. And then you have got the prism angle A. And then you can see the incident ray here. And then you can see the reflected ray here. This is not important at this stage. There's a reflected ray here. And then what you see here is the emergent ray. What you see here is the emergent ray. You can make, you can measure the angles here. You can measure this angle of emergent ray with this surface, right? And you can measure the angle of incidence here, as you can see here, okay? And emergent angle, right? And then I'm sure you would be seeing that, you know, that the ray is traveling from here to here inside the glass. Okay, the diagram that I have drawn and the diagram that you see here are one and the same. Okay, any questions here? Okay, now I can gently, I can change the angle of incidence. Okay, see, I'm changing the angle of incidence here. So as I'm changing the angle of incidence, you saw that the diffracted ray also changed, right? And I'm bringing the angle equal to C, critical angle. Okay, so I'm making the angle equal to C. You can see this one, right? Okay, this ray of light here. Okay, so this is the critical angle. So as we have explained yesterday, it is skimming along the surface. And now further, if I make the angle, see, the angle of incidence is this, but for the critical angle that we are seeing here, the angle made by this ray, which ray? The ray which is hitting this surface. Okay, the ray which is hitting this surface becomes important. That becomes the angle of, that becomes the critical angle. That is, refracted angle becomes the critical. Refracted, the angle made by the ray on this face becomes the angle to be considered for criticality, etc. Okay, now you can see that the ray is totally internally reflected. Can you see here? See, the ray has traveled from here to here. The ray has traveled from here to here, and then it has undergone total internal reflection, and that is why it is able to come out like this.
The reflected ray hitting another surface is incident ray for that surface.
Yes. See, now you see here, this is the angle of prism. Okay, the ray is hitting this face of the prism.
Yes.
The refracted ray is hitting this face of the prism.
Yes.
And then after hitting here, this ray is going out like this. Okay, and that means the ray is totally internally reflected here.
But it was skimming along the surface.
That is, I changed. See, your problem is, you know, when I'm doing somewhere, you go in between. See, I kept the angle like this. right? You can see this angle is angle of incidence. Okay? Now you can see that the ray is skimming. Can you see? Hello?
Yes, sir.
Now it is skimming along the surface. So I have adjusted the angle of incidence such that the angle made by the refracted ray on this face is critical angle. Not this angle. This angle becomes the critical angle. Got it?
Yes, sir.
No, if you are not clear, I will explain. Don't worry, you say, sir, it's not clear. God has given all the provision. See, for critical angle, I am taking into consideration this angle, this refracted ray. So this one, if this is equal to C, then the ray will skim along the surface. Got it?
Yes.
And if this angle is greater than C, then it will be totally internally reflected. Okay? So that's precisely what you have to see there. Right? You want to see something more here? Hello? Now you see, I am increasing the, so now I am going to increase the angle of incidence. You can see now the ray is coming out of this face. Can you see? Hello?
Yes, sir.
You should see, this is the, what is this? This is the prism angle. This is the base of the prism. This is the base of the prism and this is the prism angle. Clear? And now you see, I am changing the angle of incidence. See, there is something which all of you, let me see whether you can observe. See, I am increasing the angle of incidence. Look at the angle of refraction. Look at the angle of refraction. Emergent angle. Okay, you can see that, you can watch out the emergent angle, right? The emergent angle, see, so for this angle of incidence, see, the emergent angle means this angle. Hello, this angle.
Yes, sir.
This angle is the emergent angle. Okay, because this side is perpendicular. This is perpendicular to the prism. Got it?
Yes, sir.
Any question here?
So you told if
Louder.
angle of incidence increases, then it will become equal to critical angle. Here it is.
Listen here, angle of incidence is increasing, then there is a refracted ray. There is a refracted ray. So I don't know what you will be doing when I am showing something. This angle of incidence I am increasing and decreasing by rotating this. And this angle is changing. This I2 here, R2 is changing.
But that also increases.
That also increases. That also increases, decreases according to this. That also increases, decreases according to this. But now don't get, see, observe. This glass surface and this glass surface are not parallel to one another. They are not parallel to one another. Okay, so therefore, when you draw the ray diagram, you will not get that way where you are seeing in the case of
Rectangular glass.
yes. Okay, so here it is going to be different. So here, if this angle of refraction decreases here, this angle will increase. You can draw the ray diagram and see. See here, supposing I'll take this angle, see this angle as a R1. Okay, this is R1 and this angle made here is R2. So R1 plus R2 will be equal to the prism angle. Prism angle A. When for minimum deviation, there is a condition called minimum deviation, right? Okay, minimum deviation means, what I would like to say here is, you see, if you are a keen observer, you will understand this. So online students, I suppose you are following, right? So here, here you see this angle of, this is the angle of incidence, right? Right? And here there is some angle of incidence. You can see here. See, now I am increasing the angle of incidence. So what happened to the refracted ray, the angle of emergence here? There is some angle of emergence here. Okay. Now here you see, I will go on decreasing the angle of incidence. I hope you are seeing that. Hello. You look at the emergent ray here. Okay. Look at the emergent ray here. So you are changing. See, now I am going to make the angle of incidence perpendicular to this surface. Can you see? Hello? Now the emergent ray is completely doing what? Total internal reflection. Okay. Then see, I am taking the angle of incidence on this side. You can see here. Hello? Now also you will see that it is coming out. You can see here the ray that is coming out here. So understood? So here this is 90 degrees incidence. So either I turn it this side or this side. The emergent ray is coming out here, and what you see here is something called as minimum angle of deviation. Minimum angle of deviation. Okay, that means, as yesterday I taught you, there is something called as angle of deviation. I'll show that for you. See, you can see here, this is the angle of deviation. Hello, this blue color. Hello, can you see? So this angle of deviation keeps on, see, as the angle of incidence decreases. You can see here, I am keeping it at some point. Okay, some point. This is some angle of incidence, right? I hope you can see the diagram also very clearly here. You can see here. The diagram here. So this is the angle of incidence. Okay. Now I am going to decrease the angle of incidence, or I can say, okay, now you see, I am going to decrease the angle of incidence. Okay. Now as I am decreasing the angle of incidence, you have to draw the proper ray diagram, right? Then you will get this deviation angle. What is this deviation angle? Can you see here? This is the incident ray, this is the refracted ray, and this is the angle of deviation. Okay. Now this angle of deviation will keep on increasing. Can you see here? Hello? It is increasing as I am decreasing the angle of incidence. It is increasing. Can you see that increasing? I'll wait. You are able to follow? So as I am decreasing, the angle of incidence is, the angle of deviation is increasing. Hello, can you see? Yes. Now it is 90 degrees. The angle, see, now whether it is total internal reflection, don't worry. The angle of deviation is something. Not 90 degrees. Something. The angle of deviation is something. Now I am taking the incident ray on this side of the perpendicular. Normal. Okay. Now again you see it is coming back. It is coming back. Can you see? Yes. The emergent ray is coming back. It's again coming back on this side. Okay. So what I would wanted to point out to you is, you see here, this is a very important observation that you have to do. Right? So the important observation that I wanted all of you to do here is that if you draw a graph of the deviation versus angle of incidence, okay, then you are going to plot the graph. What is this? This point is what? For some angle of incidence. Hello, are you with me? Yes, sir. So now for this, so there is some angle of incidence I1, there is some angle of incidence I2, then you will get the point reached. Okay, like that you will get different points. So there will be a point here, which is ID I will call it as, ID I will call it as. So here this graph will be like this. Okay, that is the angle of deviation as we increase the angle of incidence will decrease. It will reach a minimum point, this deviation, this angle. Okay, and then once again the deviation will increase. That's what you saw.
Yes, sir.
Okay, so this angle of deviation. So this angle is angle of deviation, minimum angle of deviation. Okay, hello, are you with me?
Yes, sir.
And for a particular angle of incidence, you will get this, right? And at that time, you will find that the refracted ray will be parallel to this base. The refracted ray will be parallel to the base.
At the minimum angle.
Yes. So for a particular angle of incidence here, okay, for a particular angle of incidence here, right? Then this angle of deviation will be minimum. Otherwise, it will be larger. That's what we saw there.
Yes, sir.
Got it? And at that point, the refracted ray will be parallel to this base. Got it?
Yes, sir.
So now, if you see, if you complete this quadrilateral, which quadrilateral? AEN-M. AEN-M. If you can complete this quadrilateral. Okay. Now, what you see here is that see. Now, what is this angle? 90. This is 90 because this is normal. Hello.
Yes, sir.
90, 90. So A plus this angle, whatever is this angle, theta. A plus theta will be 90 degrees. Hello.
Yes, sir.
A plus theta will be 90 degrees. Right? And now R1 plus R2 plus theta is 180 degrees. R1 plus R2 plus theta is equal to 180 degrees. R1 plus R2 plus theta will be equal to 180 degrees. Okay, and when this line is parallel to this line, then this angle will be equal to this angle. That is R1 plus R2 will be equal to R. Hello, are you with me?
Yes, sir.
So theta will be equal to 180 minus 2R. Theta
How
will
that
be
R is equal to that R, sir?
louder.
How that R is equal, I mean, the angle of refraction is equal to that angle.
That's what. See, if this line is parallel, man, if this line is parallel to this line, if this line is parallel to this line, okay, see, this line is parallel to this line,
Yes, sir.
okay, and this angle is 90, this angle is 90,
Yes, sir.
okay. So now you can use geometry and do a bit of geometry here. So if this is 90, this is 90, then A plus theta will be equal to 90 degrees. A plus theta will be equal to 90 degrees. Okay. So look at that. So you will get theta is equal to 180 minus 2R. So you will get here A plus, instead of theta I am going to write here 180 minus 2R will be equal to 90 degrees. Okay. So that gives you 2R will be equal to 2R will be equal to, I will transfer 180 here, it will become minus 90. Hello.
Yes, sir. Yes, sir.
Then there is already minus. So I will transform the sign there. Then I will get here what? I will get here this side. What will I get?
2R is equal to 90.
2R is equal to?
90.
2R is equal to not just 90.
Minus 90.
2R is equal to A plus 90. A plus 90. You are going to get. Clear? Hello?
So this is minus A or A?
See, I will transform 2R this side, 90 this side.
So A also was transferred that side.
Here also?
What answer?
No, I made a mistake here. What is the mistake I made? I made this should be 180 degrees. A plus A is 180. Sum of the angles and quadrilateral is 180, no?
Yes, sir.
So, hello. So this should be 180. So this 180 will cancel. So I will get here R is equal to A by 2. R is equal to A by 2. Got it? So here for minimum deviation, this R will be equal to A by 2. This is a standard thing in a prism. This is a standard calculation in a prism. Okay? Then you can go on to prove that the refractive index of the prism mu will be equal to sine of A plus D by 2 divided by sine of A by 2. You can prove this. So the refractive index of the prism can be found out like this. That is, you take a prism, you will be given the angle of prism. You can also measure it. Hello, protractor on. Huh? Then by experiment you will calculate the minimum angle of deviation just by turning the prism. So you will get this value, you will get this value. Substitute this value, then you will get mu. And also that for a particular angle of also you will get the value mu. So this is the way to find the refractive index of a prism. Given, if you are given a prism of a particular angle, you can determine. That's the whole exercise. Got it? Hello, online students, did you get it? Hello?
Yes, sir.
Fine. Any questions here? Ask.
So here in this case, the minimum angle of deviation was what?
You have to find, you have to determine. You have to determine. Okay. So what you have to do is, here you see, this is the incident ring. Hello? This becomes what? This becomes the angle of incidence. Right? Hello?
Yes.
Now you can see that in this case, right? So the ray that is coming out of the prism, the ray that is going to come out of the, see, you have to conduct this experiment. You have to conduct this experiment with due diligence, right? So you can see this is the emergent ray here. Okay, so you should draw a line from this point to this point. See, now here it is incident at this point. Huh? So from this point, and it is emergent at this point. Hello? So you will draw a line here. And there is a perpendicular here. Right? There is a perpendicular here. So you will measure this angle here. So you will draw a perpendicular here and measure the angle of refraction here. So you have to locate these points and draw the ray diagram. Right? And then only you will be able to get those things. Okay? You have to conduct this experiment. Anyway, you will be doing it when you come to PUC. But right now only I am just demonstrating this to all of you to get a realistic view of how things are happening. Clear? Okay? So you have got minimum angle of deviation, prism equation, etc. I have taught you slightly higher than what you are supposed to study in your 10th standard. This almost completes one phase of learning the prism. Okay? And all these things are important. Then only you will understand lenses properly. That's the whole exercise. Okay? Okay. Shall I take off the experiment? Is it clear?
Yes, sir.
So what if we take the incident ray and it hits the edge of the prism?
That is the
Edge of the prism.
edge of the prism means how?
One corner. The
One?
axis of the prism is there.
You want it to touch the corner of the prism.
Yes, sir.
Like this. Okay. So now you only tell me what are the possibilities that can happen here. So if you treat the edge, and if you draw the ray diagram there, okay. So there also you draw the normal there, etc., etc. Okay. So now here you see this is the angle of incidence. Of course, you will not see any critical angle and all because the ray is traveling in rarer medium and entering denser medium. You will get the concept of critical angle when the ray is traveling from denser medium towards rarer medium. Okay. So now, right now, what you can see is there is a ray which is coming out here. Here. Can you see?
Yes, sir.
So that is what is happening. So the ray is hitting this point, right? And then hitting this point inside. The refracted ray is traveling from this point to this point. And then it is coming out. Okay? That's what happens. Anyways, good. Okay, so when you go to PUC, you will get a lot of prisms and you got to, enjoy this. Okay? Okay, fine. So I will demonstrate that with. Okay, so now you can see that there is a laser beam acting on this side of the prism. Can you see? Hello?
Yes, sir.
And then you can see the emergent ray coming out here. Can you see? Hello? It is coming out here. Hello?
Yes, sir.
See, now I am turning the I am turning the what? See, you can see the laser beam here. So you can see this is how the ray is traveling from this point to this point. Hello,
Yes, sir.
right? It is traveling from this point to this point. This is the prism angle. That's important because it has three corners. You don't confuse. So that's why I kept this strip here. Okay? So
Always that color is the.
always no. See now, no. See now, you are making the ray to hit this surface. You are making to hit this surface, and then you are going to see everything. So this surface becomes the plane where the light is incident, right? And then it is refracting this side, etc., etc. So this side becomes the base. So now here you see the ray is incident here, and it is not coming out of this face. It is coming out of this face. Got it? Can you get a feel of it? So now see. Now what am I doing? This angle of incidence I am increasing. Angle of incidence I am increasing. I hope you can see this. This is the angle of incidence. See, there is a line here, man, which is perpendicular to the prism.
Yes, sir.
So this is the angle of incidence. Now, okay. Now you see, it is almost skimming.
Yes, sir.
Now you see, the light is. Mr. Murthy, be careful. See, the light is coming out of this face. So because now you know, wait. Okay, it's coming out here. Now I will keep on decreasing. See, now it is coming out of this face. Can you see? It is coming out of. This is now exactly skimming. Now you can see it is coming out of this face. Right? Hello?
Yes, sir.
It's coming out of this face. See, it's coming out of this face. Can you see?
Yes,
You can see how beautifully it is happening. Right. So you need to understand things like this. So with single beam also I'm saying. See, sometimes it is coming out of this face, sometimes it is coming out of this face. So if it is coming out of this face, then it is total internal reflection. If it is coming out of this place, it is total internal reflection. Here it is coming. If it is coming out straight here, it is skipping. Got it? Anyways, thanks for the Almighty. He has made all this. You are able to see, the experiment and its analysis. That's important. Okay. So usually we go to the laboratory, we conduct experiment, and then we come back and do the analysis. But here on spot you can do, and you can really get a more realistic view of all this. I suppose all of you enjoyed it.
Yes, sir.
Okay, fine. So shall I take it off?
Yes, sir.
Go back to the theory? Yes, thank you.